My research interests are the resilience of the built environment, focusing on natural hazards, but also infrastructure management and optimization in cross-sectoral and multi-actor setting, which will mainly be the subject of today. Um, I would like to start with an observation that relates to participatory design. One day I was living in Italy, and one day I was cycling somewhere in Italy, and the cycling route was something like that. It has triangular shape where cyclists have to go all the way before they can go to the other direction. So they have to make this round. And after some time passing by the same place, I noticed that the cyclist decided to change the cycling route, and it became something like that. And here it's clear that cyclists thought that the original route is not really efficient for them, so they started to go over the green area here, just in the middle, just to avoid wasting time. And from this story, from this example, it's clear that the cyclists were not really included in the design in the first place, so they were not really asked about their preference, because the designer probably valued having green area probably over having maybe an efficient route for the cyclist. That's one example of non-participatory design, which we'll be talking about today. And this is another example that's maybe is familiar to you. This is familiar situation where you as a pedestrian come out of a road and you find yourself in the middle of a highway. And the only way to cross it is just to walk a large distance until you find a crosswalk. So you often see people just crossing in the middle of the highway and trying to time themselves so they do not get hit by the cars. And this is another example where not really all stakeholders have been taken into account when designing a system. Of course, there are a lot of depth to every example I'm giving. I mean, for the decision that are being made, but it's clear that some of the parts, some of the stakeholders, some of the users are not really happy with the final output. So this is the outline of today's presentation. First, I will introduce the notion of participatory design by highlighting the major elements that make this approach different and special. Next, I will discuss the process of participatory design and its main steps. And of course, I will walk you through some tools that you can utilize and use when designing participatory systems. And after that, I will tell you a bit about, I will share some stories and some examples of today's participatory system just to inspire you on how we can really, on existing participatory systems. Then I would like to introduce to you a recent NVO project I was working on, and it's called D2Me, or Design to Manage Interconnected Infrastructure. And this project actually had a multi-actor nature, and there were different parties involved in this process, and that's why I think it's very relevant to today's presentation. Of course, finally, we will draw some conclusions and key lessons that you should take with you. So let's get started with participatory design. Yeah, so I want to start with what we usually do when designing systems or processes. We do non-participatory design, and that's the opposite, of course, of participatory design. Non-participatory design is normally accepted, and it's really acceptable for designing, non-participatory systems or non-complex system that can be easily reviewed after feedback. So if you have something that's simple, then you can just create it, and then you ask people and then review it afterward. But if you think about complex systems such as infrastructure, it's really hard to be redesigned once constructed because it's already there. So you have to do proper design. So they have to be designed properly, because once they are executed, they will remain there for a long time. And this method of non-participatory design, which we usually do by default, lead to major losses. But even non-participatory design has multiple approaches. So for example, here we have something called the designer-centric approach. And in this approach, the focus is on the system that's to be designed, and the designer, which are these people here, are the source of information. So they decide upon everything. And here are some questions they ask themselves when designing the system that's in place. whatever the system is. So they ask themselves, what features does it have? And what problems does it solve? And how can I build it? And from these questions, we cannot see any, user or stakeholders that's involved that's part of these questions. So it's just oriented toward the system, and the user is just out of this. And so this is designer-centric approach. But there is this person who would say, well, maybe there are stakeholders that they are going to operate or use the system, and maybe we should take them into account. And then they are slightly moved towards the user-centric approach. So from the designer-centric approach to user-centric approach, where the design of the system is conducted by a team of professionals, which are these people, considering the user's need. So now, compared to the previous one, we are thinking about the user's need. And maybe your design questions should then look something like that. So what does the user want, and what do they need, and how can we support the operators? So now we can see mention of user and operator. So we mention the users when designing. So it's not only oriented toward the system that's to be designed. However, taking stakeholders into account, only taking them into account by itself, is still not participatory design, because most probably we are making assumptions about stakeholders' needs and desires when answering these questions. For example, if you ask yourself these questions, then you try then you make assumption when answering these questions. So you relate, for example, to your own experiences. But if you ask two different users about their desire and need, probably they are going to tell you two different things, right? So you are in the middle here. So you are taking them into account, but you are not really incorporating them in the design. Okay. And so what's participatory design? Well, participatory design is designing a system that adds the user, so the end user, to the team of professionals. So now the end user can produce content and make decisions on, for example, functionalities. So they are not only included in the design or taken into account, but they are really, acting in the system. So the designer now are not decision makers, but are facilitators. So they just help the users, contribute toward designing the system. So they are now included. So it might seem to you as an easy process moving from the designer-centric approach, which is the first one we presented, to participatory design approach, but it's not, because this is the focused journey from just blindly caring about the system you are designing, the first one, to including the actors and shrinking your own presence a bit, to shrinking your own presence even more. So you are now not really deciding, but you are just helping the users to contribute toward it, and moving the design to the design problem to what the participants are experiencing with each other. Okay, so you can now see this journey. You can now see the difference between every approach. So we would like to really arrive here, and it's not intuitive because most of us are really stuck in this location here, about taking user into account, but not really asking them or not really letting them contribute towards the design of the system. So we are stuck here. Okay, now that I defined participatory design, so I would like to mention a few things about the process and challenges we usually face when doing participatory design. So to introduce the steps of participatory design, I would like to play this short clip. However, they do refer to participatory design as co-design, but for the purpose of this presentation, they should be the same thing. Enjoy.
Co-design is a design approach aimed at actively involving end users, customers, and other relevant stakeholders in the design process to ensure the outcome meets their needs. We're talking about co-creation applied to design with a focus on active collaboration between users and designers. A core concept of co-design is that users are experts of their own experience. Research and design are not done on behalf of the user, but with the user. A co-design process or workshop is usually based on 4 steps: engage, understand, ideate, and validate. In the first step, we learn from each other and set the challenge. In the second step, we focus on user needs to gather key insights for each stakeholder. In the third step, we co-create design concepts and build prototypes. And finally, we check the validity and the co-created solution by testing and evaluating the resulting prototype with end users and other stakeholders.
Great. Could you please, Mark, confirm if the sound was clear?
The sound was
Because
very clear, yes.
great, that's perfect. So again, so these are the four main steps of participatory design. First, we have engage. And in this step, we gather as much information as possible about the involved stakeholders as well as their interrelations. So we let everyone really engage in the problem. So everyone would like to, that we want to include in the design, we let them engage here. And this is, of course, the responsibility of the facilitator who should handle this. Okay, and then we have the understand phase two, where we immerse ourselves with the problem to be able to identify the needs and the goals of the different stakeholders. And these needs and goals, of the different stakeholders will be the starting point to develop any solution later on, because the solution should really accommodate these needs and goals. And we have the prototype, ideate or prototype, where the needs and goals that we've already collected before are used to develop a prototype because we would like to test ideas. So we have to have prototype. And here it's important to cluster and prioritize the ideas, since you might have conflicting ideas. So if you go and ask two different people about their need and desire and their what they would like to get out of a system, they might tell you two different things. So how can we handle this conflict? And whose opinion should we go with? All right. And of course, that's one of the challenges I'm going to talk about later on. And finally, we do the validation. So we validate all the ideas in this step, and we test the idea. And if necessary, we can go for another iteration. Yeah, so here I would like to tell you that there are already some tools that help us, achieve the objective of every step here. For example, for the first and second step, which are the engage and understand, we can use a couple of methods like series gaming. We can just open discussions and focus discussion and to let everybody engage and understand. And we can use a lot of creative communication means to help with these two steps. And for the prototype, we can use, for example, participatory modeling. We can use systems modeling. And then we can validate using also variety of methods, like we can use key performance indicators to make things simple, to just evaluate the idea that we've come up with, also, or of course, evaluation metrics as well. So here, just to tell you that there are methods that we can use to achieve our objective. Now, but of course, we might face some challenges when designing participatory system. I wouldn't say that's an easy process, but if it's done properly, it can really yield a lot of benefits. For example, we have four main challenges here. We have the language challenge, the conflict, the complexity, and the resources. So for the language, so for example, if you go and ask a user about their opinion for something, if you ask them to rate something, if it's low or high, they might tell you low or high, but what does it mean to be low? What does it mean to be high? And how can you interpret it? Because also these are kind of, relative measures. And how can we transform them into quantitative descriptors? So if you want to, transform low into a number, then how can you do it? The conflicting objectives. Different people will tell you different things. They will need different things. So how can you handle this conflicting objectives into your final output? So whose opinion are you going to go with? It's resource intensive. Of course, it needs skills and you need to invest time in it. But if you can see the benefit of such approach, then you might be really willing to invest in these two things. And finally, the complexity, because if you think about infrastructure, that's really complex system. If you want to design it and you want to apply participatory system design approach, then how can you simplify this huge system into something that's manageable? Yeah, but luckily we have some methods to handle this. For example, for the language, we can use inference systems like fuzzy logic. It helps us transform language into numbers. For the conflicts, we can use multi-objective optimization or multi-criteria decision-making that help us accommodate everybody's objectives into our final solution. Of course, we have to do some compromise, but at the end, you are really including everybody. Training programs to have the personnel, the qualified personnel in order to handle this. And finally, there are some ways to model systems or to simplify complex systems into less complex system, like, you can use indicators, to represent your system. So there are challenges, but we can read that we have some tools to handle these challenges.
One question was, is there a maximum amount of participants in these types of projects that you identify with these different types of stakeholders?
Yeah, well, it depends on your system, of course. You just have to do stakeholder analysis to see who are the potential stakeholders, and then you can, of course, invite representatives, some people that really represent the whole population of that stakeholder, so they can participate. Okay, in the design process, there is no maximum time, but more stakeholders means more. You need more skills to manage the whole process. Okay, great. So let me move to and show you some examples and some success stories of participatory systems or methods to handle participatory systems design. So as an example, I would like to introduce this serious game, which can really serve steps 1 and 2 in the procedure, which, if I recall, they were engage and understand. And so it's called Relasticity, which is a card game about urban resilience against disasters. It was developed at U Delft for teaching purposes. And in the game, the players are responsible for the resilience of a city. And they have to protect the city against stresses and adapt the city to become more resilient. So every player represents a different stakeholder. For example, you can have players that's responsible for the economy, one for the community, and one for the nature, and we have other sectors as well. And so in this way, the players really experience the choices they are making and the consequences of these choices. So how does it work? The players roll a dice, and the dice indicates what type of shock the city is struck by. And they also have a budget, and this budget can be spent on adaptive measures in order to respond to these shocks that they are getting. Okay, so they all have to work collaboratively together in order to increase the resilience of the city. But at some point, they can have some conflict, because if you are responsible for the economy and you want to improve the economy because it's your sector, you might be also reducing the indicator of the community. So now you have to make decision whether you want to increase it on the expense of community, or probably you have to take another decision in order to go all together toward the green. So you face conflict, and you can see consequences of your decision. And this is really powerful way, this serious gaming, and compared to conventional interviews and asking for opinions, because it really involves feelings and involves, so you are really involved in the problem. So you can make decision and you can feel, the problems you might be facing, so you can make better decisions. And here I think we have Carissa, who was really directly involved in this serious game. So another example is GitHub, you're probably already aware of, which is a code hosting platform for version control and collaboration. And it lets you and others work together on projects from anywhere, and everyone can contribute codes, ideas, and they can also provide reviews to open code and open software. So just the whole community can really, contribute. Blockchain projects, for example, if you heard about that, are great examples where the whole community is working together on open projects, and it's really expected that the final product of such project will be based on a broad participation of the community and interested stakeholders, because there is no limitation. Anybody can really contribute in a systematic way, of course. And that's another example of participatory systems. Now, let me move to D2Me project. D2Me project is a project for managing interconnected infrastructure where multiple stakeholders were involved. And since there are multiple stakeholders, the participation element is there, of course. And that's why it's relevant for today's topic and today's presentation. So I just would like to show you what we have done in this project and the results that we got, and then we can maybe relate also to participatory design. Few things about this project. Well, the motivation was that, as you know, infrastructure managers face challenges to innovate and replace their assets to facilitate new societal requirements and cross-infrastructural constraints. So this research, this project seeks to develop an asset management framework to manage responsive innovation for next generation infrastructure assets. And this project was done in collaboration with 6 NG Infra partners, which are the managers of the infrastructure here in the Netherlands. Okay, so in this project, we focus on infrastructure intervention planning. So when you hear intervention, you can think about maintenance or replacement or any other activity that the infrastructure manager have to do for their assets. And that's intervention. And currently, in all of the world, different infrastructure networks are managed by different operators. And every operator plans their intervention activities separately with just little coordination with other operators. Okay? And the lack of integrated approach to manage all networks as a single system is really preventing us from getting the highest possible benefits. So, and by benefit, I mean, for example, you can think about cost of intervention or the availability of the system, because if every operator would like to go and do their intervention just separately, then the system will be less available to the user. And this is a loss for you. So if we just, do things together and we deal with it, we handle this as one system, then we might get a lot of benefits, which I will show you today. So yeah, so we have the so-called intervention planning, which is the act of planning intervention activities in specific time windows. So assume that you are operator and you have some maintenance activities you want to perform, and you know you have to plan them. So you have to know when every activity should be executed in the future, and that's the planning part. Okay, and we have two different approaches. The normal approach is the non-coordinated approach, where everybody is doing their own stuff separately, which is this one. This is intervention planning without coordination. Okay, so everybody is doing their own stuff alone. So here we have a time horizon, time span of 12 time steps. And you can think about time step as like a month or a year, whatsoever. And we have two different operators, operator A or manager A and manager B. So operator A would like to do maintenance every 3 months, like 3, 6, 9, and 12, so in the red. And operator B would like to do their intervention every 4 months. Okay, that's how they planned it. So 4, 8, and 12. So our whole system will be closed how many times? 6 times. So whenever every operator would like to do, they will execute their intervention, like 1, 2, 3, 4, 5, and 6. So our system is going to be closed 6 times. Now, what if we do it in a coordinated way and we try to, group our activities together so they are executed at the same time? In this case, B can be grouped with A, like this, and this B can be grouped with A, like this, and then instead of having 6 different interruptions, we are only having 4 of them. So we are really closing our system less time. So we have more availability of the system. So the user are going to enjoy our system more. So if we really do that in a systematic way for complex system, we are going to gain a lot of benefits out of this. So just let me restate the objective is to introduce an integrative optimization approach for infrastructure intervention planning in a multi-system and multi-actor setting. So we want to do just that, but for interconnected infrastructure, and that's multi-system, and multi-actors, so for multiple operators at the same time. Okay? So now that I mentioned the objective, I would like to show you how we actually look at our system, how we actually look at it and define it. So we have multiple elements. First, we have the operator, which is here, which is the manager of one or more infrastructure network. Okay, so and every network here is an infrastructure network. Like you can think about highway infrastructure or network to water distribution system and so on. And every network can be composed of different objects. Okay, so is made up of different objects. For if this is highway, then this can be a road cross section. This can be another cross section. If this is water, then this can be water pipe and so on. So we just break down our network into a set of objectives. And it's really important here to mention that these objects, sorry, it's really important to mention here that these objects are interdependent. So they kind of interact with each other. So just think about it. If object 5 is a water pipe and object 6 is another water pipe that's in series, then if you close one, the other one will also be closed. Yeah, so if one of these objects is unavailable for whatever reason, maybe maintenance, then probably another object will also be unavailable. So there is kind of interdependencies, which we actually model and capture in this method. Okay, and then we have the intervention activities. So every intervention here that you see is an intervention activity that's applied to one object or multiple objects at the same time. To give you an example, intervention 1 can be maintenance for object 1. Intervention 2 can be replacement of object 2 and object 3 at the same time. So we have these relationships as well that we also model. So this scheme here that you see, this is how we model our system, and we handle it in a systematic and simple way that of course can be applied to any complex system. You just have to increase it. So let me show you just through an example what I mean by interventions and what I mean by object using this simple example that we really used in the project. So this is small network that's composed of three different infrastructure networks, infrastructure types. Like we have the highway in green, we have the water network in blue, and we have a section of railway in brown. And as you can see, these three infrastructure types are intersecting at some points. So let's focus on this intersection right here. So you can see there's a water pipe that's under a highway. Now imagine that you want to replace this water pipe. So what you have to do is that you have to excavate this highway in order to have accessibility to the water pipe, right? So to do intervention on the water pipe, this highway will also be unavailable. So now you can start to think that probably it's wise to plan interventions together. So if we implement the intervention for the highway together with the water pipe, then at the same time we are doing both things, and we will not have to do maintenance for the highway later on. So our system will be interrupted only once. And you can, do the same procedure for other, intersections here and there. Okay, so we modeled out our system, but now we need to do the optimization. So we need to find the optimal planning. So what would be the optimal plan when every intervention should be executed so we are really reducing our costs? We do that in two stages. First stage is we call it intervention scheduling for individual objects. So what we do here, without going in details, we just look at every object apart, like object A, yeah, maybe water pipe, object B, highway, and so on. And we treat them separately, and we try to find the best plan for that object only using degradation modeling. Okay, for example, you come up with this plan. So for object A, it's best to do it every 4 time steps, like here, here, and here. For object B, you do it every 3, and so on. But there is no, there's no global planning yet. That's stage 2. And this first stage is really important for us because it defines some constraints for us. So we have to do it. Now, as a little exercise, if we want to do stage 2 and we want to do the global planning, So if I ask you to do, please try to group these activities together, then you might do this. So B4, probably you can move it to here. So you can implement it with A3, and C2, you can move it to here. And you implement it also together. B3, you can move it to A2. And B2, probably because the distance now is very close, then you can move it back and so on. Okay? So, and the final output would be something like that. So you have kind of grouped them like these together, and these together. Okay? And of course, this one and this one. So now before we had 7 different closure of the system, but now we have only 5 of it. That's the global planning. And of course, we could do that manually for really simple systems like I just did. But if it gets really complex, then you need a tool. You need an optimization model to do this. And this is what we do here without really focusing on the math. We do final optimization, and we try to minimize our net cost. So we try to find the optimal plan, optimal intervention plan for all of our objects so that the total cost is kept to minimum. Okay? So for example, the net cost is composed of the cost of interventions activity, the cost of service interruption, and the setup cost. And we do the optimization. Now, let me show you some results of this example. So we applied that model to this example, and I would like to show you some results here. Yeah, so this is the main outputs we get out of this model. So this is called intervention program or intervention plan, but for all interventions together. Like here we have a time horizon of 30 time steps. Okay, so we're planning for 30 months or 30 years, but I call it time steps here because I keep it generic. And here we have the 7 intervention activities that we would like to plan. And this figure shows us when every intervention must be executed. Like intervention 1 must be executed here, 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 and there, and so on. Intervention 2, similarly. So it tells you the moment, the time at which you have to execute something. And of course, this is the best plan because it yields the lowest cost. Okay, and what you see in red here is the cumulative cost of course, cumulative total cost. And the point here is the final cost. But is this final cost, how good is it compared to other methods that we already do? Is it good? And I mean, is it significantly less or not? That's why we compared the total cost to what we usually do. Okay, so we call it the individual program. So if you go and ask every operator to do their own intervention separately, and then you sum everything up, then you get this cost without mentioning numbers. And if you use this tool, you get this cost, total cost, and there is 17% less cost if you adopt this tool, I would say. And that's really significant because you're not really investing anything. You're just, grouping activities and optimizing the planning. And that's huge. Here I show how good the algorithm is because I can present to you a very, very good algorithm, a very good tool, but maybe this tool can only be applied to 5 objects. And then when you go to apply it for a complex system like infrastructure, it cannot be applied because it's computationally expensive. But for this tool, it's quite scalable. For the example that I showed you, it was a time horizon of 30 time steps, so it took just less than 1 second to run the model. But if we increase the variables, so time step to 3,000, for example, which is a lot, then it's only 80 seconds. And this is, you can see it's linear relationship between the number of variables and the computation time. This means that it's scalable. There is a potential that we can apply to complex system, which is, in my opinion, the main thing. Okay, great. So I showed you the result of D2Me. Now let's wrap things up and add with some and with some conclusions about the project and some generic conclusions as well. So for the project, there are a couple of conclusions that I think are really important to mention here. So throughout my journey working on this project, I faced some challenges, but these challenges happen to be actual problems that had already existed in this field, And to name few, we have the data sharing. Okay, so data sharing, as you can see, is not only a privacy issue. So you always hear that the data is hard to obtain because of privacy, but I noticed that privacy is not the main issue or is not the only issue, because the problem is that data you are asking for is sometimes just not available or not in the format that you want. So what do you think the solution for this is? Well, maybe we should know what is available in the databases before we can develop anything in the first place. So we have to really see what's available and then go and then develop a tool that utilizes only these data. So just to give you here just a funny example that I shared previously with someone. So imagine that you are sitting at home and you are hungry and you want to eat something, and so what would be the first thing that you do if you are hungry? Well, most of the people would think of a meal that they would like to eat, that they want to eat at that moment, and then they head to the kitchen and then they look for the ingredient of that meal. And most probably you will find one of the ingredient is not available. Then what would you do in this case? You just change the meal. But you've already invested a lot of time thinking about the meal and what you would like to eat, but you cannot do it anymore because you did not find the ingredient. Okay, so what's the better way is to just go to the kitchen, see what ingredients you have, and then prepare a meal that uses only these ingredients. And we need to do just that. So we need to go and see the data that we have, and then we develop something that uses only these data and not just do a tool, like develop a tool and hope that we will find the data later on, because we are wasting our time then. Of course, different operators adopt different approaches. So every operator or every manager, yeah, naturally have their own way of working and their own way of, they have their own data format and their own data type, which is okay, which is normal, I would say. So data coming from different places cannot really plug together because they are not really compatible and they are not organized in the same way. So what I think we should do is that we have to take a step back and make a unified data ecosystem, I would say, because this is going to be foundation for collaboration on data. But the good thing is that NG Infra, for example, are really making some effort in this direction, and they were working on kind of data ecosystem that allow everybody to share data in the same format. And finally, the participation of the user, because even if in the example that I gave you, we've talked to the we have talked with the infrastructure operators, but we did not talk to the user, like people like us. I mean, that's something we are still missing in when developing such tools. We are still in the middle, as I told you before, so in the user-centric approach, not in the participatory design approach. Few final conclusions. Well, participatory design mandates a paradigm shift from being a designer to being a facilitator. So you have to change the role. And there are many methods that can be used to design participatory systems, of course, each with its pros and cons. And finally, participatory design comes with challenges, but these challenges can be approached using existing methods as I showed you. And here, just to end this, so that statement I like, it's not about designing the optimal system sometimes, it's about designing the right system that accommodates everybody's needs, because the optimal system is really subjective to whoever you are talking to. That's pretty much it. Thank you so much for being present today, and I hope the presentation was informative. Now, if you have any point you would like to discuss, feel free to do so.